If you keep a messy room and you lose your glasses, how many places could they be? On the desk, under the bed, or even in your jeans pocket from yesterday? There are literally 1,000 places in your house that something can get lost. But you don't systematically search every single location in a grid-like pattern. You walk into the room and somehow zero in on the most likely spots that they would have been. You might check the nightstand first, and then the bathroom counter, and maybe the couch. Within a few minutes, you're able to find them. Your brain just solved a search problem that could have taken you hours if you approached it from a systematic standpoint. So, welcome to the most fundamental problem in intelligence. One so basic that every movement of your conscious life actually depends on it. Yet, you've probably never noticed. Cognitive scientists call it the relevance realization problem. And it might be the single most important thing that your brain actually does. Every moment in your life, you face an overwhelming flood of information. Right now, as you watch this, your visual field contains multiple millions of photons hitting your retinas. Your ears are processing countless sound waves. Your skin might even be detecting pressure, temperature, and texture. Your memory contains billions of stored experiences and facts. The number of thoughts that you could potentially have right now is essentially infinite. And somehow, out of this overwhelming chaos, you're able to focus on what matters. You're watching this without noticing how bright the lights in the room are, or the feeling of your clothes against your skin. You're simply thinking about relevance, realization, instead of remembering what you had for breakfast a few days ago. Your brain is constantly solving the problem of what to pay attention to, what to think about, what to remember, and most importantly, what to ignore. So we can think about it this way. Imagine you have a treasure chest with 10 locks on it. For each lock, you have 10 keys, and you don't know which key goes to which lock. How many possible combinations exist? 10 keys for the first, times 10 keys for the second, times 10 keys for the third, and so on. That's 10 billion possible combinations. You could spend years trying every single combination. And if you scale this up to the problems that your brain faces every day, how many ways could you interpret the sentence that you just heard? How many possible responses could you give to a simple answer? The numbers become so large that they actually become meaningless. You navigate this space effortlessly, instantly, and continuously. And this is what makes artificial general intelligence so difficult to create. We can build machines that beat grandmasters at chess and create algorithms that generate convincing texts. But we cannot build a machine that can learn chess, then learn to swim, then learn to write poetry, and then learn to have a conversation at a dinner party. But humans do this routinely. The difference comes down to relevance realization. A camera solves the problem of recording sight and sound, but it can't learn history, and it can't figure out how to be kind in different social situations. You can do all of these things because you possess something deeper than any specific ability. You possess the capacity to figure out what is relevant and what isn't. And so, the strangest part about relevance realization is that it actually happens before almost everything else that we think of as thinking. It's like the idea of cloud watching. A cloud to you can seem like a lot of different things. Maybe a bunny rabbit, a shape, another person, a facial structure, literally anything that your brain can make a connection to. But how many aspects does that cloud actually have, or properties it possesses? Every time you form a thought about something, or every time you use a representation like a word or an image or a concept, you're selecting a tiny subset of all possible properties and aspects. Out of the infinite possible ways to think about something, you are miraculously able to focus on one. And this selection process happens before you even think about it. John Searle pointed out in 1992 that all representations involve seeing as. You see something under a particular aspect. But which aspect? Because there are infinitely many to choose from. The representation itself can't tell you which aspects actually matter, though. Something deeper must be selecting them. Something that operates before you have words or concepts or categories. And rules face the same problem. Take the rule, be kind. It's simple, but being kind to a new puppy means one thing, and being kind to your adult child might mean something completely different. The rule of be kind doesn't specify its own conditions of application. And this goes way back to Aristotle and Plato. Rules don't contain within themselves the information about when and how they apply. If you try to create rules for applying rules, then you get infinite regress. More and more rules, each requiring more rules to specify when and how they apply. Reasoning faces an even more dramatic version of this problem. Consider literally any proposition, like cats are mammals. How many implications flow from this statement? A really large number of them. If cats are mammals, then cats are animals. And if they're animals, they're living things. And the list goes on and on. But each of these implications connects to countless other implications and branches endlessly. When you make an inference and when you reason from one belief to another, you are selecting from all the logically possible implications. You're choosing the ones relevant to your current task. This means the things that we typically think of as the core of thinking, like representations, rules, and reasoning, all presuppose something much more fundamental. They all require the ability to zero in on what's relevant from an overwhelmingly large space of possibilities. And this ability operates beneath your conscious awareness. It's mostly transparent to you because you never really notice it happening. The psychologist George Miller pointed out something remarkable about this. We have limited working memory, limited attention, processing power, and time. So every moment, we must focus our cognitive resources on a tiny subset of all possible information and thoughts. The vast majority of what we could be thinking about gets filtered out pre-consciously. The zeroing in happens automatically and invisible to you. It's like the classic example of when somebody points out that you don't really have to focus on breathing. And then when somebody points it out, you have to now focus on your breathing to realize that it's happening. Something that was in the background became at the forefront of your mind. But notice how many other things still remain in the background. The sound of distant traffic, the memory of your first day at school, the logical implications of the last sentence that you read. And it's all filtered out because they're not relevant in this moment. Attention gets treated as this spotlight that we consciously direct. But attention presupposes relevance realization. Before you can direct your attention somewhere else, something has to determine that this location is worth attending rather than the infinite other locations that you could focus on. Before consciousness even enters the picture, before you make any deliberate choice, your brain has already solved the relevance problem. And this explains why general artificial intelligence remains so difficult despite all of our advances. We can program specific solutions to specific problems and create algorithms that follow explicit rules. But we can't create systems that figure out what's relevant across multiple domains and across changing contexts. A chess program knows that certain board positions matter and certain moves are worth considering. But it doesn't know this because it solved the relevance problem generally. It only knows this because humans pre-solved the relevance problem for chess and encoded that solution into the programming. The program cannot transfer this ability to Go or poker or even tennis. Each new domain requires humans to solve the problem all over again and encode the solution. Yet, on the other hand, you can do all of these things and then apply them metamorphically to business strategy. And notice how they relate to personal relationships. You are transferring relevance patterns across multiple domains and finding these structural similarities and generating new frameworks on the fly because of it. You're doing general purpose relevance realization. The frame problem, as it's called in AI, refers to this exact challenge. When something changes in the world, which of your beliefs should you update, and which should you keep the same? If you learn that your friend moved to a new apartment, you update your belief about where they live. But you don't update your belief about what color their eyes are or whether they like pizza, because those facts are not relevant to the situation. Humans solve the frame problem millions of times a day without even noticing that we're doing it. Just as an example, I'm writing a book right now, and I wanted to change everything from past tense to present tense, because I just realized that it would make more sense and it would draw the reader in a lot more than trying to use the past tense for everything. And so I sent my manuscript into ChatGPT and said, change the tense, because I was already 100 pages deep into the book. And then instead of just changing the tense, ChatGPT kept asking me, how would you like this rewritten? Would you like it in this context or this context? Would you like me to update this chapter? And it was asking questions one by one by one. I eventually just got sick of it asking me questions and did it myself. It was faster and it was less stressful to just change it than it was to keep answering questions about what to change, how to change, and in what context it should be changed. The frame problem is really just another face of the relevance realization problem. Cognitive scientists have been working on this since at least the 1970s. Some of the brightest minds in artificial intelligence have devoted their careers to understanding how this works. But despite decades of effort, we don't have an answer. We understand the pieces of the puzzle, but the full picture still remains very elusive to us. And part of what makes this problem so difficult to study is that relevance realization is transparent to consciousness. We don't experience the process of zeroing in on what matters. We only experience the results. The glasses appear to us from their location on the nightstand. The relevant implication of a proposition seems obvious. The appropriate way to apply a rule in a given situation feels natural to us. And so, if we're not doing something consciously, then science cannot measure our brain waves to figure out how we do it. In order for scientists to discover how the human brain works in this way, our brain waves actually have to tell a story. But to us, it's not a story. It's an unconscious thing that we do. And so it can't be measured or studied. And so it's hard to translate that into general artificial intelligence. The capacity to learn new domains, transfer insights across multiple contexts, and to figure out novel solutions still remains a purely human ability. And at the core of general intelligence lies relevance realization. The ability to figure out what matters in a new situation and what aspects to focus on, which patterns to recognize or implications to pursue, still remains human. This is why measures of general intelligence are so predictive. They predict how well you'll do in school, better than your previous grades, and how well you'll perform at a job better than interviews. General intelligence measures your fundamental capacity to solve the relevance problem across diverse domains. But the relevance problem shows up everywhere. And the implications extend far beyond understanding intelligence or even building better AI. Relevance realization sits at the forefront of what makes us human and what makes us cognitive agents. An agent that is a self-directed knower and actor. Someone who can determine the consequences of their behavior and change that behavior to achieve a goal. And doing this requires constantly solving the relevance problem. Which actions are relevant to which goals? So, the search for understanding this continues. Neural network models are beginning to capture aspects of this process. But the full answer remains one of the deepest mysteries in cognitive science. Every time you find your glasses, understand a sentence, or figure out how to say the right thing in a conversation, you are demonstrating a capacity that we don't even understand yet. And if we can't understand it, we can't yet replicate it. But when we do, the implications are going to extend far beyond having AI try to change certain things about our papers and our writing. Because this capacity that is so transparent that nobody notices that we're doing it is the invisible intelligence that makes everything else possible. So, with that said, thank you guys so much for watching. And as always, don't forget to like, comment, and subscribe. And I'll see y'all next time.